Today we will discuss about decision tree induction, right? It is the learning of decision trees from class level training tuples, right? So today we will discuss about in detail about this algorithm, right? To find the best attribute. Now, some basics of decision tree that already you know about the decision tree. So I'm just uh, uh, pointing some points, right? I'm just saying some points regarding the decision tree. So what is it? That it is a tree-shaped diagram used to determine a course of action, right? And each branch of the tree represents a possible decision and the occurrence of reaction, right? And already we are familiar with this decision tree, right? I mean, suppose you are calling to the customer care of a operator. So there you have seen that. So it is asking for to choose different menu, right? And if you select a menu, so automatically it will again redirect you to sub menus, right? Means it is a branching one. Means if you select one node, so then again it will branch into several sub nodes. So this is the decision tree. So, and ultimately, when you come to the conclusion or come to the solution, then you will find the answer. Suppose you want to talk with the customer care. So different steps are there, right? So if you choose one for the English like that, and if you press the one, then it will ask you the different menus. From there you need to select one node. Again, in the next step you need to select another node, and finally you need to press a note to communicate with the customer care, right? So this is the also the structure of the decision tree. Fine. So it's a flow like tree structure where each internal node denotes a test on an attribute. Each branch represents an outcome of the test, and each leaf node or the terminal node holds a class level, right? And the topmost node is the root node, right? So the problems that decision tree can solve is why we will use the decision tree in classification. So classification problem can be solved by the decision tree, right? A classification tree will determine a set of logical if then conditions to classify the problem, right? For example, discriminating between three types of flower based on a certain features, like that, right? Decision tree can solve the regression problem also, right? The regression tree is used when the target variable is numerical or continuous in nature, and we feed a regression model to the target variable using each of the independent variables, right? And each split is made based on the sum of square errors. So that we will discuss later, right? Now we'll concentrate about the classification problem, right? What are the advantages of decision tree? So simple to understand, right? Interpret and visualize, right? It's an advantage. uh, for the preparation of the data, so little efforts are required, right? And it can handle both numerical and the categorical data also. So these are the advantages of the decision tree, right? And another advantage is that non-linear parameters, right, does not or don't affect its performance. Non-linear parameters don't affect its performance. So these are the advantages. And what are the disadvantages? That overlifting, right? Sorry, overfitting. Overfitting is one of the disadvantage of decision tree. Overfitting occurs when the algorithm capture noise in the data. Means if you have the uh, redundant data, right? If you have the anomalies in your data set, that it causes the overfitting. That we will discuss. High variance is another disadvantage of the decision tree. Means if the model can get unstable due to the small variation of data, right? So it affects the decision tree. This is the another disadvantage. A highly complicated decision tree tends to have a low bias, right, which makes it difficult for the model to work with new data. So these are the disadvantages of the decision tree, right? So now the question is coming in mind that how are decision tree used for classification, right? So given a tuple x, so given a tuple x for which the associated class level is unknown, the attribute values of the tuple are tested against the decision tree. Fine. So a path is traced from the root to a leaf node, right? Which holds the class prediction for the tuple, right? So this decision trees can easily be converted to classification rules, right? Now the question is that why it is so popular. The construction of decision tree classifiers does not require any uh, prior knowledge or the parameter settings, right? So it is appropriate for exploratory knowledge discovery. And these decision trees can handle multidimensional data also, right? So their representation of acquired knowledge in tree is intuitive and generally easy to assimilate by humans. Fine. The learning and the classification steps of decision tree induction are very simple and fast, right? So decision tree classifiers have good accuracy also, right? This decision tree induction algorithm means have been used for many areas like medicine, manufacturing, production, financial analysis, astronomy, molecular biology, right? So these are the application areas where you can where the decision tree induction algorithm is used. Fine. So this is the training set we have taken for the example, and this is the induction tree, sorry, a decision tree based on the algorithm. So that we will discuss that how we can represent the decision tree, right? Now coming to some history of this decision tree induction, right? How this induction algorithm was proposed. So during the late 1970s and early 1980s, J. Ross and Quinlan, J. Ross Quinlan, a researcher in machine learning, developed a decision tree algorithm known as the ID3, iterative dichotomizer. This is known as the ID3. Later, this work expanded on earlier work on concept learning systems, and it is described by the Hunt, Marin, and Stone. Quinlan later presented C4.5, which is a successor of ID3, which become a benchmark to which newer supervised learning algorithms are often compared. Later in 1984, a group of statisticians that Brayman, Friedman, Olson, Stone published the book, The Classification and Regression Trees, which is known as the CRT, which describes the generation of binary decision tree. Right. So this ID3 and CART were invented independently of one another at around the same time, but they follow a similar approach for learning decision trees from training tuples, right? So this ID3 C4.5 CART adapt a greedy approach in which decision trees are constructed in a top-down recursive divide and conquer manner, right? Again, I'm saying so. This approach is the decision trees are constructed in a top-down recursive divide and conquer manner, and most algorithms for decision tree inductions also follows a top-down approach, right? Which starts with a training set of tuples and their associated class levels. The training set is recursively partitioned into smaller subsets as the tree is being built, right? So now we will discuss about the algorithm. So this is that also you can write, or you can write this decision algorithm also. So right, so we will discuss that this algorithm. The algorithm is called with three parameters, right? D, the attribute list, and attribute selection method, right? We refer to D as a data partition. Initially, it is the complete set of training tuples and their associated class levels. The parameter attribute list is a list of attributes describing the tuples. An attribute selection method specifies a heuristic procedure for selecting the attribute that best discriminate the given tuple according to the class. Means it will find you the best attribute to split, to design the decision tree. Fine. So this procedure employs an attribute selection measure such as information gain, gain index, that we will discuss. So these are the methods. The tree starts as a single node, capital N, representing the training tuple in D. Right? So now I am just describing these steps. So the tree starts as a single node, capital N, representing the training tuple in D. Fine. So if the tuple D are all of the same class, right? Same class means like this. This no is the same class, yes is same class, right? So these are the same class. So if tuples and D are all of the same class, then node N become a leaf and is labeled with that class. This step 2 and step 3, right? Means if you get the pure node, pure class, means they all belong to the same class, then what? Then it becomes the leaf, right? Means all the tuples, all belongs to the same class, all belongs to yes or all belongs to no. Then that n becomes a leaf, right? And these steps 4 and 5, these are the terminating conditions, right? Otherwise, the algorithm calls attribute selection method to determine the splitting criteria. Means if these are not leaf node, then you need to apply the attribute selection method. The splitting criteria tells us which attribute to test at node n by determining the best way to separate or partition the tuples in D into individual classes. Right? We need to find the best splitting criteria, means which attribute will be the best to split. Right? Here you have seen that we have started with the edge. So this is the best splitting attribute. So how to find this best splitting attribute? This is done by the attribute selection method. Right? The splitting criteria also tells us which branches to grow from node n with respect to the outcomes of the chosen test. And more specifically, you can say the splitting criteria indicates the splitting attribute and may also indicate either a split point or the splitting subset. Right. So the splitting criteria is determined so that the resulting partition at each branch are as pure as possible. As pure as possible means they belong to the same class, right? Partition is pure if all the tuples in it belong to the same class. Okay. Next, the node n is labeled with the splitting criteria which serve as a test at the node. A branch is grown from node n for each of the outcomes of the splitting criteria. Right? The tuple D are partitioned accordingly from this step 10 and 11, and there are three possible scenarios. Right? There are three possible scenarios are there. So what are the scenarios that we will discuss? Yes. These are the scenarios. Let A be the splitting attribute and A has V number of distinct values, right? A1, A2, A3, and up to AV based on the training set. So A is discrete valued, right? Suppose A is discrete valued. So in this case, the outcomes of the test at node n correspond directly to the known value of A, right? So a branch is created for each known value like this. And partition Dj is the subset of class level in D having the value Aj of A. It means we are partitioning according to each branch. So because all the tuples in a given partition have the same value of A, So A, just a moment. So here let uh, A is the discrete valued, right? So in this case, the outcome of the test at node n correspond directly to known value of A. So a branch is created for each known value, like aj, right, of A and labeled with the value. So this partition dj is a subset of the class level in D having the value aj of A, because all the tuples in a given partition have the same value for A. Right? So here you can see that depend on the colors we have partitioned accordingly the value of the attribute, right? Means the one branch is grown for each known value of A. If A is continuous valued, right? In this case, the test node at n has two possible outcomes. In this case, the node has two possible outcomes corresponding to some conditions, that there will be one split point, one is less than equal to the split point, another one is the greater than equal to the split point, like this. Means we will consider a split point, one will be less than equal to that split point, one will be greater than of this split point, right? So the tuples will be partitioned such that so d1 and d2, so d1 will hold the values less than equal to the split point, and d2 will hold the values which is greater than equal to the, sorry, greater than the split point, right? Third one is A is discrete valued and binary tree must be produced, right? So here the test node, the test at node n is of the form A belongs to SA or not, where SA is the splitting subset of A, written by the attribute selection method, right? Means here you need to find the subset of the set, and then based on this you need to perform the partition, right? So if a given tuple has value aj of A, and if j belongs to SA, then the test node n is satisfied. So two branches are grown from n. By convention, the left branch out of n is labeled with yes, so that d1 correspond to the subset of class level tuple in D that satisfy the test, and the right branch out of n is labeled to no, so that d2 corresponds to the subset of class level tuples from D that does not satisfy the test, right? So these three scenarios are there, and this the algorithm uses the same process recursively to form a decision tree for the tuples at each partitioning resulting partitions, right? The recursive partitions stop only when any of the following time means any of the uh, following termination condition is true. So what are the termination conditions? All the tuples in partition D belongs to the same class, then only it can terminate. Number two, if there are no remaining attribute on which the tuple may be further partitioned, right? In this case, the majority voting is employed. In step 5, it is already given. This involves converting the node n into a leaf and leveling it with the most common class in D. Right. And the third condition is what? There are no tuples for a given branch. That is, a partition dj is empty. Right. The condition 12. In this case, a leaf is created with a majority class in D. And then last, it is returning the decision tree. This is the algorithm. Right. It sounds like complicated, but if when we will um, discuss with the help of an example, it will be very easy. Okay. So next we are coming to this attribute selection measures by which you can find the best attribute. An attribute selection measure is a heuristic for selecting the splitting criteria that best separates a given data partition. Right. Here we are presenting the data partition as capital D. Okay. So it is a heuristic for selecting the splitting criteria that best separates a given data partition capital D of class level training tuples into individual classes. If we were to split D into smaller partitions according to the outcomes of the splitting criteria, so ideally each partition would be pure. Pure means all the tuples fall into the same class. So conceptually, the best splitting criteria is the one that most closely result to the such scenario, right? Means we will find the best splitting criteria to find or to approach to the partition should be pure. So the attribute selection measure provides a ranking for each attribute describing the given training tuples. The attribute having the best score for the measure is chosen as the splitting attribute for the given tuple. Fine. And if the splitting attribute is continuous valued, or if we are restricted to binary trees, then respectively either a split point or a splitting subset must also be determined as a part of the splitting criteria. So fine. So three scenarios are there. If A is discrete valued, second A is the continuous valued, and third one is the discrete and the binary one, right? So if the splitting attribute is continuous valued, or if we are restricted to binary trees, so we have to approach to find a split point or a splitting subset, right? To find the split to determine the splitting criteria. Okay. The tree node created for partition capital D is leveled with a splitting criteria, and branches are grown from each outcome of the criteria, and the tuple are partitions accordingly. So there are three populars at tree between selection measures there: information gain, gain ratio, and the Gini index. Fine. So here we have used some notations, right? So capital D is the data partition. It is a training set of class level tuples, right? Suppose the class level attribute has m distinct values, right? Defining m distinct classes, capital Ci, where I range from 1 to m, and let C I comma d be the set of tuples of class Ci in D, mod D and mod CID denotes the number of tuples in D and CID. This is the tuples for a particular class. This is the total number of tuple in the training set that you can say, right? So next is, so now we will discuss about the information gain. So the ID3 uses information gain as its attribute selection measure, and this measure is based on pioneering work by the Claude Shannon on information theory. Let node n represent or hold the tuple of partition D. Okay, let node capital N represent or hold the tuples of partition capital D. The attribute with the highest information gain is chosen as the splitting attribute for the node n. Means the attribute with highest information gain will be chosen as the best attribute. The attribute, so this attribute minimizes the information needed to classify the tuple in the resulting partition and reflects the least impurity in these partitions. Okay. So before that, we need to find the expected information, which is known as also entropy, right? So before coming to the information gain, you need to first find the entropy. Entropy is what? This is the measure of randomness or impurity or unpredictability in the data set. Right? Entropy is what? It is the measure of the randomness or impurity or unpredictability in the data set. And information gain is what? It is the measure of decrease in entropy after the database is split. Right? So we will find the information gain. So what is the entropy? First you need to find the entropy then. So what is the entropy? I needed to classify a tuple in D. So this is minus summation of pi log pi to the base 2, where I range from 1 to m. Where pi is what? This pi is the non-zero probability that an arbitrary tuple in D belongs to class Ci, right? And pi is nothing but it is this mod of Cid divided by mod of D. Okay. And why this log function is there? The log function to the base 2 is used because the information is encoded in bits. So this info D is just the average amount of information needed to identify the class level of a tuple in D. Right. So now suppose we were to partition the tuples in D on some attribute A into V. Means suppose we are to partition the tuples in D on some attribute A having V distinct values, A1 up to A1, A2, and up to AV, as observed from the training set. Okay, that you have seen, right? That here, so we have different partitions are there, different class levels are there. Okay, different values are there. In case of age, we have three values. In case of income, we have three values. Okay, and different class levels are also there. So in this case, so if A is discrete valued and these values correspond directly to the V outcomes of a test on A, the attribute A can be used to split into V partitions like D1, D2, D dot dot dot, right? So D1, D2, D2, D3 and up to DV. And these partitions would correspond to the branches grown from node N, right? So ideally, we would like this partition to produce an exact classification of the tuple. This is very simple thing. That is, we would like for each partition to be pure, and however, it is quite likely that the partitions will be impure. So, how much more information would be still need to arrive at the exact classification? And this is measured by this. Right? So, after splitting into V partitions, we are just classifying this partitions, and these are the respected information for each partition. Okay, this is summation of d mod of dj, where j is 1 to v, by mod of d into that id, the entropy of that particular tuple. Okay, it will be easy, means when we will explain with the example, then it will be easy. And what is the information gain then? The gain is defined as the difference between the original information requirement based on just the proportion of the classes and the new requirement obtained after the partition on A. So this is the original information, right, which is based on the proportion of the classes, and this is what, this is based on the partition on A, and the difference between two is ultimately the information gain, right? So it tells us how much would be gained by branching on A. So the attribute A with the highest information gain is chosen as the splitting attribute, best splitting attribute at the node N. Okay. The attribute A with the highest information gain is chosen as the splitting attribute at node N, and this is equivalent to saying that we want to partition on the attribute A that would be the best classification. Fine. So now check it. This is our training data set. Okay, we have 14 tuples are there. So now you can see, so there are two classes are there, right? One is class P, yes, and there is class N, no. So first we will find the entropy. So first we have taken H. And first we will check, means you have to check each attribute, which one is with the best. So we are starting with the H. Then we will check the income, then we will check the student, then we will check the credit rating. Okay. The first one is H. So in H, if you consider youth, so 1, 2, 3, 4, 5. Okay. So 5 youths are there. Among them, 3 no and 2 yes. So this is 2 yes and 3 no. Fine. If you consider the middle age, so 1, 2, 3, 4 middle age are there. Among them, 1, 2, 3, 4 are yes. Okay. And similarly, if you consider the senior, so there are 3 yes, 2 no. So these are the values of the entropy. These are the value of the entropy by this formula. Okay. Clear? These are the value of the entropy based on this formula. So now we will find the um, information. So these are the entropy. So now we will find the information or of particular that attribute. So here, in case of H, okay, so in case of youth, total number of class is what, 5. So this is 5 by 14. Okay, so this is the 5 by 14. This is the entropy of this according to this example, right? Now I am just coming to this. Next, according to for the middle age, this is 4 by 14 because total number of class is 4. Okay, and then this and plus 5 by 14 and this is 0.694. I think it is given there, it is not there. Okay. So here the gain is what? So this is the sorry, total entropy, right? This is the total entropy. So what is the total entropy? The total how many? One, two, three, four, five. Five no is there. So this is minus 5 by 14 log 5 by 14 according to, sorry, according to formula. Okay, so this is 5 by 14. 9 yeses are there. So minus 9 by 14 log 2. This is the entropy. So this is 0.940. This is the entropy of the entire class, right? And this is the information for the age attribute. So what is the gain? So this is 0.246. Fine. Here also you can split like this, right? This I23 is what? This I23 is nothing. This is minus 2 by 5 log 2 by 5 to the base 2 minus 3 by 5, right? Log 3 by 5 to the base 2. I mean, this is 2 yes and 3 no. So same like this we can find here. Here also 4 yes, 0 no. So it will be what? It will be 4 by 4 log 4 by 4. So basically it is giving 0 because log 1 is 0. So that will be 0 because it is actually the pure set. Is it giving the pure value? Here also it is 3 yes, 2 no. So it will be minus 3 by 5 log 3 by 5 to the base 2 minus 2 by 5 log 2 by 5 to the base 2. So after doing the calculation, we will find this value. So this is the gain of HA. Similarly, if you can find for the income, student and credit, these are the gain values. So here, what I told you, the maximum gain value will be the best splitting criteria. So here you can say the age has the maximum gain value. Clear? So that's why this age is chosen as a best splitting attribute, right? So age 1, 2, 3. So here all are belongs to same class. So these are actually the leaf node. Here also again we will do the same processing based on this three criteria. Again we will find the entropy and the gain of income, gain of student, gain of rating, and then we will find the which one will be the best splitting criteria. Here is also same, that again we'll find this, and here also we will find which one is the best splitting criteria to come to this, means ultimately to come to this decision tree, right? So this is one of the attribute selection measure by which you can find the best splitting criteria. Okay, but how can we compute the information gain of an attribute that is continuous valued? So in the example, we have chosen a as a discrete valued, but if a is continuous valued, then what we will do? Suppose we have an attribute a that is continuous valued. So for such a scenario, we must determine the best split point for a, right, where the split point is a threshold on a, if you consider the age. So we will consider that, suppose 30. So which are less than 30, that we will consider, which are more than 30, that we are consider, like that. Okay, so we first sort the values of a in increasing order. The midpoint between each pair of adjacent values is considered as a possible split point. Okay, so if there are v values of a, so there will be v minus 1 possible splits after evaluation. Fine. Means suppose there are four values. So first two adjacent values, for first two adjacent values, we will get one split point. For second and third adjacent values, we will get another split point. For third and fourth adjacent values, we will get the third split value. So for four values, we are getting three split values. So similarly, for v values of a, we will get v minus 1 possible split values. Fine. So for example, the midpoint between ai and ai plus 1 is ai plus 1 by 2. So if the value of a are sorted in advance, then determining the best split for a requires only one pass through the values, right? So here the number of partitions are basically 2, right? Means here the value of v is 2. So mean according to this equation, right? To find the this one, the point with the minimum expected information requirement for a is selected as a split point for a. So one will be a less than equals to split point, another will be a greater than split point, like this. Okay, so for continuous value you can split like this. Clear? Next is the gain ratio. The information gain measures is biased toward test with many outcomes. Means it prefers to select attributes having large number of values. For example, consider an attribute that act as a unique identifier, right, such as the product ID. So a split on product ID would result in a large number of partitions, like each one containing just one tuple. So because each partition is pure, the information required to classify dataset D based on these partitions would be what? That info D, like previous example, it will be 0 because it's giving you the pure set. So therefore the information gained by partitioning on this attribute is maximal, and such partition is useless for classification. Right? So the successor of ID3, C4.5, uses an extension to information gain known as gain ratio to overcome this bias. It applies a kind of normalization to information gain using a split information value defined with info D. Right? So what was the info D? If you remember, it is what this is the formula, right? So you just modify this one to minus summation of mod dj by mod d into log dj by mod d to the base 2, right, where j is 1 to v, means if there are v partitions. So this value represents the potential information generated by splitting the training dataset capital D into v partitions, okay, corresponding to the v outcomes of a test on attribute A, and for each outcome it considers the number of tuples having that outcome with respect to the total number of tuple in D. Okay. So it differs from the information gain, right, which measures the information with respect to classification, that is acquired based on the same partitioning. And what is the formula? It is the gain of the particular attribute by the split info, okay, this one, right? Suppose if you consider the that same attribute, right, this, suppose gain income is what? So what are the values of income? That is, this is three partitions are there. This is low, medium, and high, right? Low, medium, and high, and this containing. So if you consider the low, how many lows are there? Four lows are there. Six mediums are there, and four highs are there. Fine. So then, what will be the split info? D of this income according to this formula. So this is what? Minus 4 by 14, because 4 lows are there. 3 values are there, low, medium, and high. So 4 lows are there. So this is minus 4 by 14 into log 4 by 14 to the base 2, minus 6 by 14 log to the base 4, 6 by 14, and this 4 lows, 6 medium, 4 highs. So what is the split info? This is the value. Then what is the gain ratio? So already you have seen that what is the actual gain? This is 0.029, right? This is the actual gain for this income attribute. Then what will be the gain ratio? This is 0.031. So by using this gain ratio also you can find the best attribute. Okay. Same, the attribute with the maximum gain ratio is selected as a splitting attribute. Means if you find with respect to the gain ratio, you will see that the gain ratio of H will give you the maximum value, right? So that you can do, you will do in practice, that you will find the gain ratio of other attributes and you will check that which one is giving the maximum value. It is your home task, right? So next one is the Gini index. It is used in cart. It measures the impurity of D. It is actually measuring the impurity in D. Okay. So what is it? This is 1 minus summation of pi square, where I range from 1 to m. So pi is what? That already have discussed, that pi is what? This is mod of CID divided by mod of D. Right? Pi is the probability that a tuple in D belong to class Ci and is estimated by mod of CID divided by mod D. And the sum is computed over m classes. The Gini index considered a binary split for each attribute. Okay. So just listen very carefully. So where so let's first consider a case where A is discrete valued attribute having V distinct values like A1, A2, A3, dot 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 up to AV. To determine the best binary split on A, we will examine all the possible subsets that can be formed using known values of A. Right? And each subset SA can be considered as a binary test for attribute A of the form it's A belong to SA or not. Right? If A has V possible values, then there will be 2 to the power V possible subsets according to the set rule. Means if there are three possible values are there. Suppose in case of income, so three possible values are there, right? Low, medium, and high. So the possible subsets will be what? Low, medium, high, right? Low, medium, low, high, medium, high, low, medium, high, and empty set. So these 8 subsets are there. So from this 8 subset, you can exclude the power set, low, medium, high, and the empty set because they do not represent a split. So ultimately, there are 2 to the power v minus 2 possible ways to form two partitions of the data D based on the binary split. Means there are 2 to the power minus 2 possible ways are there, right? So when considering a binary split, so we computed a weighted sum of the impurity of each resulting partitions. Okay. For example, if a binary split a partition D into D1 and D2, so then it is the formula, right? Gini D for a particular for attribute. This is mod of D1 by D into Gini D1 plus mod of D2 by D Gini D2. So for each attribute, each of the possible binary split is considered. For a discrete value attribute, the subset that gives a minimum Gini index for that attribute is selected as a splitting subset. Right? Minimum Gini index for that attribute is selected as the splitting subset. Okay. And if the reduction in impurity that would be incurred, so here also you can reduce the impurity reduction is there. This is the ultimate Gini index and minus Gini index for the particular attribute. So the attribute that maximizes the reduction in impurity is selected as the splitting attribute. Right? The attribute that maximizes the reduction in impurity or has the minimum Gini index is selected as the splitting attribute. And this attribute either its splitting subset or split point. If you use the discrete value, then it will be the splitting subset. If you use the continuous valued attribute, then it will be the split point. So it together form a splitting criteria. Now just coming to the example. Okay. So if you consider about that example, so there are 9 yes and 5 no's. Right. There are 9 yes and 5 no's. So what will be the Gini index? So this is 1 minus, this is what? This is Pi, this is CID. So 9 classes for yes. So this is 9 by 14 total class square minus 5 for no. 5 classes are for no. This is 5 by 14 square. So this is the value. Okay. Now we are considering the income. Okay. So income has 3 values: low, medium, and high. So since there income has 3 values, so it will be decomposed into 8 subset, right? So among them 2 subsets will be will not consider 2 subset. One is the power subset, low, medium, high. Another one is the empty subset. So now I'm considering this subset, low, medium, right? So if you consider this subset, so there are, according to the table, you can see, as if I go to the table, now you can see. So how many lows are here? Low and medium, right? One, two, three, four, four low. One, two, three, four, five, six, six medium. Okay. No. One, two, three, four, four low. Four low and six medium. Okay. So there are four low and six medium. Now here you can say one thing that so this would result in a 10 tuple partition D that condition that income belongs to low and medium, right? So 10 tuples are there which belongs to low and medium, right? So here 1, 2, 3, 4, 4 lows and 6 medium. So total 10 tuples are there belongs to the medium, low and medium, sorry, and other 4 tuples which are not belongs to low and medium, which are basically belongs to the high, right? So this is the D2. So what will the Gini index then? Acha, now among this 10, among this 10, how many no or yeses are there? You just check it. 1, 2, 3, 4, 5, 6, 7 yes. 7 yes and 1, 2, 3 no, right? And among these 4, there are 2 yes and 2 no, right? Clear? So this is this. So this is 10 by 14. Again, I am finding the Gini index. So this is 7 yes, this is 3 no, and among these 4, this is 2 yes and 2 no. So this is the value. Okay. So the Gini index value for split on the remaining subsets are. So this is the Gini index of income belongs to this low medium. So we'll find the Gini index of other subsets also. So similarly, the Gini index value for split on the remaining subset are this. Is for the subset of this and this, and 0.450 for the subset of this and this. So therefore, the best binary split for the attribute income is on this because it minimizes the Gini index, right? And evaluating the age, we obtain that youth, senior, or middle aged as the best splitting age with the Gini index this. The attribute student and credit rating are both binary with Gini index 0.367 and 0.429 respectively. Fine. So the attribute age and splitting subset youth senior therefore give the minimum Gini index overall. So it is 4.5, it is 0.458, this is 375, this is 367 and 429 also. Right. So if you consider, so the minimum Gini index overall, so this gives the minimum Gini index overall with the reduction in impurity is this. So therefore, the binary split H results in the maximum reduction in impurity of the tuples in D and is returned as the splitting criteria. Yes. By using the Gini index also you can see that H is considered as a best splitting criteria. Okay. So there are other attribute selection measures are there, right? Now, so which attribute selection measure is best? You can ask. So all measures have some bias. It has been shown that the time complexity of the decision tree induction generally increases exponent means exponentially with the tree height, right? So hence measures that tends to produce shallower tree may be preferred. However, some studies have found that shallow tree tends to have a large number of leaves and higher error rates. So despite several comparative studies, no one attribute selection measure has been found to be significantly superior to other. So most measures give the quite good result, right? I'm coming to this example. So before that, I'll give another selection measures. This is the comparison, right? That you can check. Other attribute, other selection measures are also there. That so these are the different attribute measures are also used. We will discuss this overfitting and tree pruning. Overfitting is a significant practical difficulty for decision tree model. It happens when the learning algorithm continues to develop hypotheses that reduce training set error at the cost of an increased test set error. Right. So too many branches reflect some anomalies due to the noise. So there are two approaches are there to avoid this overfitting. So one is the pre-pruning that stops growing the tree earlier before it perfectly classifies the training set. And one is the post-pruning that allows the tree to perfectly classify the training set and then post-prune the tree. Right. Practically, the second approach of post-pruning overfits the tree is more successful because it is not easy to precisely estimate when to stop growing the tree. Fine. So how does the tree pruning work? So there are two. So in the pre-pruning, the tree is pruned by halting its construction early. That I told you. Means by deciding not to further split or partition the subset of training tuple at a given node. So upon halting, the node becomes a leaf. The leaf node hold the most frequent class among the subset tuples or the probability distribution on those tuples. So when constructing a tree measures such a statistical significance, information gain, Gini index, and so on can be used to assess the goodness of a split. Right. If partitioning the tuples at a node would result in a split that falls below that specific threshold, right? Okay, so if partitioning the tuples at a node would result in a split that falls below a specified threshold, and then further partitioning of the given subset and is halted. So there are difficulties in choosing an appropriate threshold. High threshold could result in a oversimplified trees, right? So and whereas the low threshold could result in a very little simplifications. So the best approach is the post pruning, which removes the subtrees from a fully grown tree. A subtree is given node is pruned by removing its branches and replacing it with a leaf. The leaf is labeled with the most frequent class among the subtree being replaced. So here you can see that notice the subtree A3, right? It is in the unpruned tree. But this is the unpruned tree. So here you can see that the most common class with the subtree is class B, right? So in the pruned version of the tree, so in the pruned version of the tree, the subtree in question is pruned by replacing with the leaf class B only. Okay. Again, I'm saying that here that if you check consider this subtree A3, so the most common class within this subtree is the class B. You can see if it is yes, yes, then class B, and if it is no, then class A. So there is no significance of class A. Okay, so we're just removing this part. So in the pruned version of the comp tree, the subtree in the question is pruned by replacing it with the leaf class B. Okay. Alternatively, pre-pruning and post-pruning may be interleaved for a combination approach or for a combined approach. Post-pruning requires more computation than pre-pruning. No single pruning method has been found to be superior over all others. Right. So some pruning methods do depend on the availability of additional data for pruning. This is usually not a concern when dealing with the large databases. Right. Although prune tree tend to be the more compact than their unpruned counterparts, so they may still be rather large or complex. Right. So decision tree can suffer from two factors: repetition and replication. Repetition occurs when an attribute is repeatedly tested along a given branch of tree. Right. See here you can see repeatedly age less than 60 means here we are repeatedly testing an attribute less than 60, less than 45, less than 50. So all are belongs to this less than 60, right? So we are repeatedly testing the same attribute. Another one is what? This is the replication. Means duplicate subtree exist within the tree. So here you can see that the duplicate subtree is also there. This one and this one, right? So this situation can impede the accuracy and comprehensibility of a decision tree, right? The use of multivariate splits can prevent these problems. Okay, fine. So these are the things of the decision tree to discuss about. So now I'm coming to the example, right? So this is the example, very famous example of the another example of the play golf. So this is the training data set. So which one among them should you pick first? So there are four attributes of their outlook: temperature, humidity, right, windy. So these are the class sets. So which one among them you should pick first? So how do we choose the best attribute, or how does a tree decide where to split, right? So there are four things are there. So first, what we will do, we will find the entropy, right? So there are 9 yes and 5 no, and this is the entropy, right? So which node will be the root node among these four? Outlook, humidity, temperature, or windy? Let me discuss. So in case of outlook, there are three attributes: sunny, overcast, and rainy. In sunny, we have 2 yes, 3 no's. In overcast, we have all 4 yes. And in case of rainy, we have 3 yes and 2 no. Okay. So which one among them should you pick first? So in case of outlook, what you have seen in case of outlook, so now I will find the gain, right, according to uh, this formula, this one. So what is this? How many? So two uh, yes and three no is there. So this is 2 by 5 and this minus 3 by 5 log 2. So this is the value. Similarly for the overcast all are pure. So this is what? This is 4 by 4, right? Log 4 by 4 to the base 1. So since log 1 is 0 and this is this minus 0 is there. And in case of rainy there are 3 yes and 2 no. This is the value, right? So information for outlook is there. So what is the gain? So gain is what? This is this one. Okay, this one. Okay, so what is the total gain? Total gain is what? This is information from the outlook, that this is total. um, in case of outlook, so how many are there? This is total 5 for sunny. This is 5 by 14. I am just doing this one. Okay, this one. Total 4 overcast is there. Total 5 sunnies is there, and these are the respective value of each. So this is 0.693. So what is the overall gain? So total entropy minus this. So this is 0.247. Okay. So same we will find for the windy, humidity and temperature also. So similarly for windy the value is 0.048. For humidity this is 0.152. For temperature this is 0.029. So that you will do in home. This is your home task. So you will find each info of that particular attribute of this value. You will find individually these values and you will find individually the gain, right? This is your homework. So here you can see that this the gain of this age attribute, sorry, this outlook attribute is maximum. So this is the root node. Fine. This is ultimately it belongs to all the pure class. So we will not further branch will this. So what will be in this two among this three, temperature, humidity, and windy? That again we will find the same way, right? Here you can see that here again we have find the all the values by the same way, means we have find all the gain respectively, that will be which one will be here, humidity, temperature or windy. So that again we have find here, right? So here you can see that outlook humidity has the highest gain value. So here then it will be the humidity, right, like this. And same that here will be the wind. So that we will do that which one will be here as the best attribute and which one will be here as the best attribute, that we will find, right? Like this. So this is all about the decision tree induction. Okay, just practice very carefully. B- I hope this, then it will, you will understand what is the algorithm, right? So whatever the attribute measure we will use, it is ultimately to determine the best attribute, right? We have to frame the conditions that split the data in such a way the information gain is highest. Okay, and the gain can be calculated by finding the difference between the subsequent difference of the subsequent entropy values after the split. And then we will try to choose the condition that gives us the highest value gain, and we will do that by splitting the data using each condition and checking the gain that we get out of them. And the condition that gives us the highest gain will be used to make the first split. Okay, so thank you.